In this section 3.7, we're going to be finding different equations of lines in our coordinate plane, but to get there, we have to establish some pieces of those lines first. First of those pieces is something we can call the slope. You might be familiar with slope as this concept of what we call the rise over the run of my graph. And when we count rise over run on a coordinate system, count rise first and then run in that order. This basically is going to tell me how steep or how flat a line is going to be rising. In cases where it's too difficult to count out on my graph, or if I don't have a graph at all, we also have another way to find the slope, and that's to compare the coordinates. We can find the difference of the y coordinates, and that's going to stand in for the rise, again, basically how much your graph is going up and down. And we're going to divide that by the difference in your x coordinates from one point to another, and that's again basically telling you how far your graph is moving from left to right. We can generally tell a slope, or a few things about a slope rather, just by looking at it. So we can tell, again, basically we're going to have 4 different kinds of slopes that we're going to be focused on: positive, negative, 0, or undefined. And just by telling from the side of my slope, even if I don't know what the specific slope is, I can tell if we're going to be falling or rising as we move to the right on my graph. A slope of 0 specifically is going to mean a horizontal line, and an undefined slope is going to mean a vertical. It's going to make a little bit more sense when we see the bottom of this page for those pieces. But for the first two, for a positive and negative slope, this is a great way to check answers real quick, as long as I have any slope that's positive. Just like I read from left to right, we're going to read our graphs in that same direction. So we want to read our graph as rising in this case, rather than like falling in that opposite direction. And same thing, if I read a graph with a negative slope, it should look like it's falling as we go from left to right. Again, that's the direction I'm going to read this in. And that's going to tell me that I have a negative for my answer if I was to find the slope myself. Again, 0 slope, that's going to be our horizontal line. Undefined slope is going to be our vertical. And we get a little bit more into what that looks like with the slope formula. So if I wanted to find the slope of this line, for example, we could count out if the first one is asking for line B. We could still count your rise over your run. And in this case, it looks like to get one from one point to another, we actually have to go downwards and then to the right. So this does look like, again, just by basic picture of a negative slope. But if I want to find that slope exactly, and again, let's say if this was too hard to count, I could find that by using what we have as that slope formula. So that's the difference in your y's for my numerator, difference in the x's for my denominator. And if I use a few points, it doesn't actually matter which order you solve that in. So let's say if I consider y2 that second coordinate for negative 2, and if I think that the first y coordinate is positive 2, again, y2 minus y1 is going to be negative 2 minus 2. One thing I do want to keep in order though is that I want to stick to the same order that I started with. So if I started with my negative 2 for my first y coordinate and then subtracted it in that direction, I want to start with 4 for my first y coordinate, or my first x coordinate rather, and subtract it in that direction. So that's going to be 4 minus negative 1. And if I get negative 4 for my numerator and 5, it looks like, remembering that minus negative is going to be like adding a positive for my denominator. If I get negative 4 over 5, we can just answer that generally. Okay, as long as I have a negative divided by a positive, my entire answer is negative. And if I get a slope of negative 4/5, that is matching again what we expected for a negative slope, because as I read that graph from left to right, it looks like it is falling downwards as I go to the right. So negative slope is going to be fine. Again, that just tells us, as if I was counting, that's going to be going down instead of up as I count to the right. If I was to find the slope of line D, you might be checking and seeing that it is just a vertical line. We do want to make sure, though, that if I was to use that same slope formula, this could still work with the formula itself. So if I was to check the slope of that line, we know again from the example that was given from before, if I have any kind of vertical line, it would have an undefined slope. But we also have a way to back that up using my slope formula. If I try to use those coordinates, again, you could either do 0 minus negative 2, or you could do negative 2 minus 0 if you're trying to calculate that. As long as you keep that consistent, it's just going to be 4 minus 4 on the bottom. If I ever try to divide by 0, and if you try this on the calculator, it's going to tell you there's an error as well. We can't divide by 0, so that's why we say that a slope of a vertical line is undefined. You have rise, but if I don't have any run, we can't divide by 0 for that slope formula. If I was going to try the same thing on A looks like, again, just by matching my graphs from the top, it does look like it'll end up with a positive slope. And if I was to find the slope by using that slope formula, or again by counting, if I wanted to count out from one point to another, we go, it looks like up and to the right to make that slope positive. But again, if I just use these two coordinates, and in either order, we just want to subtract 7 minus 3 for your two y values. One thing you can't do, let's say if you pick 7 minus 3, I can't then start with 2 and subtract 5. I do have to keep that in the same order. So if we choose this to be our first x and y pair, and this is our second x and y pair, I want to keep that consistent from top to bottom. So I can do 7 minus 3 over 5 minus 2. That finds a slope of 4 over 3. Let's say if you guys were to find that backwards, again, let's say if I did 3 minus 7 on top instead of 7 minus 3, we would end up with the same answer either way. because notice that we'd also have to switch the order of your x's in order to keep that in the same pair. I get -4 divided by -3, and since a negative divided by a negative turns out to be a positive slope anyway, we do get that same solution. So just know that it doesn't really matter which order we subtract them as long as we keep that order consistent. If I start with this coordinate for the y's, I want to do the same thing with the x's. And if I was to start with a 3 for the y's, so again going this direction, I would have to go that same direction for the x's. So you just want to make sure that direction is consistent. If I was trying to find the answer for our last line, looks like C, again, I could just match the fact that it looks like a zero slope because it looks like a horizontal line. But just like our previous answer for part B, it looks like this is backed up by the slope formula as well. If I was to try to plug those 2 points in, could be again like 7 minus 7, 5 minus 1, or 1 minus 5 is going to end up giving us the same answer no matter how I subtract those. Because if I get a difference of 0 on the top, again, this is like saying that my graph has 0 rise divided by really any kind of run. That's going to be a result of 0 because we know that 0 divided by anything is still just going to be 0. So 0 slope, different from an undefined slope. Another place you might see this, or another term you might see for undefined slope, is like the term no slope. But again, no slope, a little bit confusing. I would just stick to the term undefined because a lot of people confuse no slope with 0. You just want to remember that undefined, because I was dividing by 0, or if I was taking 0 divided by something else, that's going to give you a different answer. So a little bit different in terms of how we eventually list those answers. The 2 forms of line that we're talking about from earlier in the notes is going to be our slope-intercept form and our point-slope form. So just like the names imply, a slope-intercept form, might have seen this kind of equation before, is structured as y equals mx plus b, where m, the coefficient of your x term, that's going to be the slope of your line, and b, that's going to be the y-intercept, or basically the place on your graph where it crosses the y-axis. So if I was trying to graph a line using that form, again, this just matches our y equals mx plus b for our first problem. It looks like the slope of this line, the coefficient from the x, is just going to be 2/3. Again, think up 2 and then right 3 if I was trying to count that out on my graph. And then for our b term, again, that's our y-intercept. If I was to try and graph this line, I actually want to start with that point first. I know that this graph is going to cross this line rather, is going to cross the y-axis at that intercept of 1. So that's the point that I can start with. And then if I follow my slope from that point on, I can count up 2, right 1, 2, 3, and that's going to place us here for our next coordinate. And if I follow that same pattern up 2, 1, 2, 3 to the right, we can get other points that follow that pattern as well. Something that's going to be useful is to be able to reverse that same slope. So we count this as up 2 and always to the right because we always read this to the right. But if I also want to find a few points in the other direction, I can also go down 2. If I go 1, 2, 3 to the left, and that's going to place me along the same line. Just going to be a helpful tip for, let's say, if I run out of room in one direction, I can always just graph it in both directions on my graph. And it looks like if I could just connect those, that's the line that would pass through those points, again, with a slope of 2/3 and a y-intercept. That part was important, the y-intercept of 1. Our next line uses our different form, so we call that our point-slope form. Again, kind of like the name implies, they're going to use the slope from our line, and they're also going to use a single point from the line, where we split up the coordinates into an x-coordinate and a y-coordinate. So if I was trying to graph this example, again, this is written in my same point-slope form, and that's what it looks like from up above. Our point-slope form, we just need 2 pieces of information, just like slope-intercept. Again, slope is going to be the coefficient in front of your parentheses. So if I see -2, that's going to stand in for my slope. But again, this is like going down 2 over 1. If you're thinking of, again, -2, if you want to look that to look like your other slopes, down 2 over 1 is going to be the same thing. And again, this coordinate that's going to end up on our graph, so it breaks that up into 2 coordinates, x-coordinate and a y-coordinate. That's given by, again, the piece that we're subtracting from y. So if it's y minus 3, that's going to be a y-coordinate of 3 in our graph. It's a little bit kind of reversed because we have the y-coordinate first. And then again, if your x-coordinate, if it says x plus 3, remember that in the formula itself, it's the opposite sign. So the opposite sign from a positive 3 is going to be a -3. So you do have to watch out for this formula. You are going to be changing a couple signs. Since you're subtracting the y value and you're subtracting the x value, you do want to make sure if it's a minus in the formula, it's going to end up as a positive for your y-coordinate. And if it's a positive from the formula, as we saw from the x, it's going to end up as a negative for that coordinate. So it will change that sign. But same as how we started our last graph, if I want to put this onto my coordinate system, I can start from the point that it's giving me. So 1, 2, 3 to the left, 1, 2, 3. -3, 3 is going to be the point that I can start from. And only then do I follow my slope. And again, if this is negative, I should see that this is going down 2 and 1 to the right. As I read this graph from left to right, it looks like that's going to be my next point. I could continue that pattern if I want other points along my graph. And it looks like 1, 2, I can also reverse that in the opposite direction. Remember, now we can go up 2 and left 1 if I want to picture as I go to the other side, up to left 1, up to left 1. This is going to be the line, again, following that point slope formula rather than following the slope intercept. So kind of a similar way to graph it. Again, you just want to make sure you know what coordinate you're starting from, whether that's the coordinate that's given from the formula or if it's just the y coordinate from your y-intercept. But as long as I start from that point and follow my slope, whether it's a positive slope as I go up or if it's a negative slope as I go down, that's how we want to keep those graphs consistent. Start from your point, then just follow your slope for the rest of the line. If I was to write the equation, we actually kind of are reversing our previous answer. We have a couple things that are given. We just want to get the formula from it. First one's telling me a slope. So again, that would be like your m from your equation, and a y-intercept is like the b from our formula. So as long as I just want to put those two back in the formula, slope of 3, y-intercept of -5, that's all I need to fill out that y equals mx plus b formula. But for the next one, again, if I'm passing through a certain point, when it's not necessarily the y-intercept, this is where I want to read this with that second formula we were given. Again, this is what I call my point slope form. And if I was to substitute into that form, it almost look like two x's, sorry about that. Should be the x coordinate first and then the y coordinate that we're given. So the way I'm going to read this is, again, following that formula, y minus the y coordinate, we're just going to be changing the sign and just writing that as y minus 5. And then we have our slope as a coefficient. And then again, changing the sign with your x coordinate because it's minus in the formula. Minus -1 is going to be changing that sign to a positive, so it's going to look like x plus 1. If you guys would like to try that next one, again, it does use the same two pieces, just a point that's not the y-intercept, and then the slope that's also given. So it looks like on that solution, as long as I keep with that same x coordinate, y coordinate, and stay with that same slope, slope goes in front of your parentheses. We change the coordinates, or sorry, we change the signs rather of your coordinates. So y minus 4 and x plus 1, changing the sign from that original coordinate. But as long as I have that, those two pieces of information, we would be able to graph that. Again, just putting that point, following our slope for the rest of the line. So if I was to get the equation of a line, again, notice what I start with is I start with 2 points. This is where I'm thinking right ahead to my point slope form, so the second of those two equations. If I was given the y-intercept, it would be easier to find y equals mx plus b. But if I don't start with the y-intercept, I should be able to use either one of those two coordinates to stand in for my x and my y pair from the formula. And that would complete my equation when we're ready for this at the end. First, what I'd have to start with, though, is I'd need to figure out the slope if it wasn't told to me already. But as long as I know 2 points, we can always find the slope by using the slope formula from earlier. Remember, it's the y's on top, x's on the bottom. And I'm just going to choose this as my y coordinate to start with. So y2 minus y1 is 5 minus -1. But again, we could have reversed that if we wanted to. We do want to keep that in the same order, though. So if 3 and 5 came in the same pair, I want to start with 3 and 5 first for both parts of my formula. 3 minus -2 to find the bottom part of the slope. I get 6 over 5, it looks like, which is a fraction, but our slope's going to be a fraction. And that just means if I have that, I have enough information to solve it, because I could put my formula, y minus 5 equals 6/5 and then x minus 3. Again, I'm just using this coordinate and this slope, using that with our point slope formula. That's one option for my line. And I say we have an option because I'm given the second coordinate here. So I could say, or another way to write this is to say y plus 1 is equal to that same slope, 6/5, because that's not going to change, x plus 2, which means I'm just using that other coordinate, again, making sure to change the signs when I plug that in for my y and my x. But as long as I have that same slope, it will still refer to that same line. So 2 options, again, if I was to use 2 points, we'd use either the first or the second, and that's just going to be, again, an option that I can use for my equation. So lastly, if we're looking for the equations of horizontal and vertical lines, this is not so much something to solve as it is something to show you guys. So just kind of wanted to show this as a solution. Horizontal lines are always going to make a y equation. You can think of that as basically having a certain y-intercept and then staying along that certain line because we don't have any like slope. So I have 0 slope. I can't go up and down from that. Same idea if I was to make a vertical line, although this time I would have a x-intercept. So if I have like an x-intercept of 2 and I just go up vertically from that, there wouldn't be any y in the equation. So if I use that as sort of my consistent pattern, horizontal lines are always going to be y equations. If I was to look at the horizontal line here, that's a y-intercept of 4 that we keep following. If I was using a vertical line, again, that's just going to be a vertical line that goes through 2. So using 2 as my x-coordinate and continue that. I think it's probably best to just kind of memorize which one is which. Y is always going to be horizontal. X equation is always going to be vertical. And in this case, we wouldn't need to use those formulas. We can just use whichever variable, is going to match that type of graph.